Okay, let's do a practice problem for the kinematic equations. And you can see right over here, I've got the kinematic equations listed. So there are 4 of them. And remember that they require constant acceleration. And as long as we have constant acceleration and we have 3 variables, we can find all the others. That's one of the nice things about using the kinematic equations. So in the problem that you saw, it said that a bicyclist was moving at 5 meters per second. They accelerated to 16 meters per second and it took 8 seconds to do that. And we want to find out what is the displacement. So if we do the first step, we're going to list everything for this. So our initial velocity is 5 meters per second. And we accelerated up to 16 meters per second. It took us a time of 8 seconds to do that. And we want to find out what was our displacement. So what we do is we take a look at the variables that we have listed here, and then we find one of these equations will match better than some of the others. So the equation that we're using for this one will be the second one. So I'm going to write down that equation. Delta x equals 1/2 vi plus vf times delta t. And we don't have to do any algebra for this one because we can see that our unknown is delta x, and this is also looking for delta x. So the equation as it's written doesn't have to be modified. No algebra required for this sample problem. All we do now is we put all the numbers in, with units of course. So delta x equals, we've got our 1/2, and then we put in our 5 meters per second, plus our 16 meters per second, and then our time interval is 8 seconds. Got to do a little bit of order of operations. And when we do the math, either out or on a calculator, we find that we get 84 meters for this answer. So this one was very straightforward. We found the right kinematic equation. We plugged all the numbers in with units because these of course are measurements. And then we've also got our answer with units, and we have the right amount of sig figs. Sometimes you may have to modify this equation and use a little bit of algebra to solve for a different variable, but you go through the same steps. I'll see you in class.